Two satellites S1 and S2 revolve around a planet in coplanar circular orbits in the same sense. Their periods of revolutions are 1 hour and 8 hours respectively. The radius of the circle S1 is 10 to the power 4 km. When S2 is closest to S1, find the speed of S2 relative to S1, the angular speed of S2 as actually observed by an astronaut in S1. So if I draw a setup for this particular arrangement, so I can draw it in this way. So these are the two satellite paths around moving in a coplanar circular orbits about a particular planet which I have circled in between. So the S1 is maybe moving with a velocity v1 over here. I am calling it as S1, and over here this is v2 for another satellite S2. The radius is r1 and r2 respectively. So now the first thing that we say is we will be applying Kepler's law. So if we will be applying Kepler's law, so we are saying t square is proportional to r cube. So if we apply Kepler's law, so we can write it in this way that t1 squared by t2 squared is equal to r1 cube by r2 cube. So from here I can obtain that r2 uh, cube can be written as r1 cube t2 square by t1 square. So if we put the value to obtain the value of r2 over here, so r2 can be written as, so r1 that is 10 to the power 4 cube t2 by t1 that is 8 by 1 whole square and the cube root of this entire quantity. So we will end up getting the r2 as 4 into 10 to the power 4 kilometer. So now we are coming to the linear speeds of satellite S1 and S2. So let us keep in mind the radius which we have obtained. So R1 is equal to 10 to the power 4 and this one is 4 into 10 to the power 4 and the time periods are 1 hour and 8 hours respectively. So if we calculate the linear speed for satellite S1, so we are calling it as V1, which is equal to 2 pi R1 by T1. So we can write it as 2 pi 10 to the power 4 by 1. So we obtain it as 2 pi into 10 to the power 4 kilometer per hour. And now if we calculate for the satellite S2, so if we are calculating V2, so we are obtaining it as 2 pi R2 by T2. So we can write it as 2 pi R2 is equal to 4 into 10 to the power 4 upon 8. So we obtain it as equal to pi into 10 to the power 4 kilometer per hour. So now if we write the speed of satellite S2 relative to S1, so we can write it as V2 minus V1. This we are referring as V relative. So the relative velocity of the satellite can be written as pi into 10 to the power 4 minus 2 pi into 10 to the power 4. So we obtain it as equal to minus pi into 10 to the power 4 kilometer per hour. Now the second question is asking us to calculate the angular speed of S2 with respect to S1. So the second one is asking us to calculate the relative value of angular speed. So angular speed relative value is going to be Vr by Rr. So we can refer to it as V2 minus V1 by R2 minus R1. So we can write it as 3.14 into 10 to the power 4, that is value of pi, into 5 by 18, that is we are converting it into meter per second. upon r2 minus r1, and we can write it as 3 into 10 to the power 4 into 10 to the power 3. So the value will be in radian per second. So if we solve this out, we obtain it as equal to 3 into 10 to the power minus 4 radian per second.